Hello everyone, let's talk about this LeetCode problem. It's the last problem in this context, and actually it's a hard problem. Okay, let's take a look at the problem. If you haven't raised the problem, you can take some time to raise the problem. So the description is quite messy, and there are n cars set in a line, and each car has its position and speed. So it asks us like for each car, let's calculate the time the car will collide with other cars. So if two cars collide, so their speed will become the minimum speed of the two cars. So they will not be greater. Okay, let's take a look at one example. So for this example, the first car position is 3, speed is 2. The second car position is 4, speed is 4. This one has position 6, speed 3. This one has position 9, speed 1. At first, we need to know to solve this problem, we need to iterate from last to start. Like we need to iterate from the leading car to the last car. Since to calculate the time for current car, we only need to know the cars like in front of my current car, since my current car only collide with those cars in front of me. Also, my current car may be collided with the cars behind me, but to calculate the time, we only need to know the cars in front of my current car. Okay, I is 3, time is -1, since this is the cars, like this is first vehicle, this is the leading car, so it does not collide with other cars in front of it. And it's a collision candidate, which means the cars behind this car maybe collide with this car, right? So for each car, they all can be a collision candidate. So at the end of each iteration, we need to push current index to our stack so they can be a collision candidate. Okay, next one, I is 2, and we know time is 1.5. Okay, then my stack has 2 collision candidates with vehicles 3 and vehicle 2. We know for cars behind them, for example, for cars with index 1, it may collide with 2 or it may collide with 3. It depends on on the speed and distance. We know for index 1, if this car is very fast, for example, speed is 100, then we know it will collide with index 2. Or if this car is not very fast, for example, speed is 3.1, then we know index 2 will collide with index 3 first. Then index 1 collide with them. Okay, so when I is 1, if 1 collide with 2, then we know time is 2, which is greater than result 2. We know for I is 2, it takes 1.5 to collide with the other vehicles. So index 2 collide with others first, and we cannot use 4 minus 3 as the speed difference for index 1. So we need to pop 2 here. Since it takes 2 seconds for index 1 to collide with index 2, if it collide with index 2. But we know for index 2, it only takes 1.5 to collide with other vehicles. So index 1 will not collide with index 2. And all other vehicles before index 1 will not collide with index 2. So no other vehicles will collide with index 2. Then we just pop 2. Okay, for index 1, if it collide with 3, we know time is 9 minus 4 divided by 4 minus 1. Okay, if the time is smaller or equals than result 3, or result 3 is less than 0, then it will collide with 3. So for I is 1, time is 9 minus 4 divided by 4 minus 1. And for I is 0, for I is 0, speed is 2. But in the current top of the stack, the speed is 4. So we need to pop the stack. Since the speed is too slow, so it will not collide with index 1. Okay, now my stack only has one collision candidate. Then we can calculate the time, which is 6.0. Okay, let's take a look at the implementation. First of all, we initialize the result, and we have a stack called myStack. Finally, we just return this result. As we mentioned previously, we iterate from the leading car to the last car. Anyway, for count index I, it's always may be or can be a collision candidate that all the cars behind it may collide with it. And we don't need fast cars behind current car. Since my current car is too slow, so it will not collide with faster cars. We can just pop fast cars. And this is the tricky part. For each candidate, like collision candidate in my stack, we need to say, if it's a valid collision candidate, if my current vehicle will collide with the candidate or not. If first we assume it collides with the candidate. If it collides with the candidate, we calculate the time. Then we compare the time with the result of the candidate. For example, for my current car I, it takes 2 seconds to collide with this candidate. But for this candidate, it only takes 1 second for this candidate to collide with other vehicles. So my car will not collide with this candidate. My car will only collide with vehicles in front of the candidate. And or if my candidate is smaller than 0, which means the candidate, for example, the candidate can be a leading car, it will not collide with others. So in this case, I will set my result I to count time, which means for this car, it will collide with the candidate. Otherwise, this car will collide with cars in front of the candidate, or we say will collide with the cars has greater index. Then just pop this candidate since it's not a valid candidate. Okay, so that's the implementation. It's not very easy to understand, but you can draw some examples and you will find and understand the tricky parts. The key point is here, how do we populate this index 2? Since for index 1, we find it will not collide with index 2. Since if it collides with it, we know that it takes 2 seconds, but for index 2, it only takes 1.5 to collide with others. Then as long as it collides with others, the speed will not be 3. So the previous calculation about time 2 is not correct, which means index 1 will not collide with index 2. Index 1 will only collide with cars after index 2. Then we can pop this index 2 since it's not a valid candidate now. No, it will never be a valid candidate. Okay, that's it. Thanks.